morning, good afternoon, and good evening. We are going to discuss a few more topics, and it's all about the solar-powered home. So in solar-powered home, we have three different types, three different configurations. And those are the grid-tied type, the off-grid, and the hybrid. So isa-isahin natin ano ba yung mga yan. Grid-tied type of solar-powered home is connected to the home and to the traditional electricity utility grid. This does not include storage battery. So yung off-grid naman, it is a standalone system which is completely disconnected from the electric power grid. So unlike the grid-tied, it is not connected to the utility grid, and aside from that, it has a large set of battery packs to store energy during the day. So yung sa grid-tied, wala siyang battery. Sa off-grid naman, meron siyang battery. Yung hybrid, let's just say it's a combination of two, which is connected siya sa power grid at meron din siyang battery backup, kagaya ng off-grid. So, magfo-focus muna tayo ngayon sa may grid-tied type of solar-powered home. Ayan, the grid-tied solar power system. The grid-tied solar power system, it is a solar power system which is being connected in parallel to the electric supply that goes inside the house and only functions during the day. Mamaya i-discuss natin to one by one. The excess energy that is being produced is then fed into the grid. It does not produce power at night. And during power loss, the solar power system is also in shutdown state. So bakit ganon? Bakit hindi siya nagpo-produce ng power at night? At bakit pagka nawala ng kuryente ay magsha-shutdown din yung solar power system natin? That's because wala nga siyang battery. Ibig sabihin, wala mapag-i-storan ng energy. Therefore, walang magagamit sa gabi kapag wala ng araw, at kapag nawala ng kuryente, magsha-shutdown din siya kasi connected siya sa power grid natin, sa power utility grid. So, the main purpose of the grid-tied solar power system is to save electricity. In fact, when the solar array ratings matches the electric consumption, zero bill can be attained. So, these are the basic parts of the grid-tied solar power home. So, etong una, lahat naman kailangan syempre niyan. Hindi naman natin masasabi ng isang bahay ay solar-powered kung walang solar panel. Sabi nga dyan, this is the heart of solar-powered home. So, bakit siya heart ng solar-powered home? Kasi sabi ko nga, hindi matatawag ang isang bahay na solar-powered kung walang solar panel. Because ito yung directly na nagko-collect ng sun, ng energy from the sun, at saka na i-convert into a DC power output. So, mamaya i-discuss natin kung bakit merong blue, bakit merong black na kulay ng solar panel. So, ito nga. The black one is called the monocrystalline solar panel. Tapos yung blue naman is yung polycrystalline. So these are the factors that we have to consider before buying, or kung ano ba yung mas prefer nyong bibilin. Kunwari, bibili kayo. So yung monocrystalline, in terms of silicon arrangement, it has only one pure silicon crystal. While yung poly naman, may silicon fragments melded together. In terms naman sa cost, mas mahal yung mono, yung black, tapos mas mura naman itong polycrystalline. Sa appearance, merong black hue ang mono, tapos blue naman yung poly. Sa efficiency, sabi mas efficient daw ito. Tapos mas siguro efficient din pero hindi ganoon kaano kaysa sa may black. Sa lifespan naman, tumatagal daw yung monocrystalline from 25 to 40 years, wherein itong blue from 20 to 35 years lang. Ibig sabihin, mas matagal pala ang buhay nitong monocrystalline solar panel kaysa dito sa may poly. Sa temperature coefficient naman, mas lower yung temperature coefficient na monocrystalline, making them more efficient in heat. Tapos, mas mataas yung temperature coefficient naman ng polycrystalline, kaya mas less efficient siya pagdating sa heat. So, all in all, sinasabi dito na kung gusto mo ng mas efficient, mas matagal na buhay na solar panel, ang pipiliin mo is the monocrystalline. Although, mas mahal nga lang ito. Depende pa rin sa budget ng buyer. Ayan. The second part or the basic parts ng isang solar panel is the inverter. It is a device that converts DC output of solar panel into AC. So, kung nagpo-produce ng DC output yung ating solar panel kapag nag-receive siya ng energy from the sun, ito namang inverter ay i-convert niya yung DC na yon into AC, which is standard used by all commercial household appliances. So, bakit kailangan i-convert pa yung DC into AC? The answer is, eto nga, all commercial household appliances. Meron kasi mga appliances na hindi niya kayang i-absorb yung DC. Na kailangan pa i-convert sa AC para gumana, para makapag-supply ng power dun sa mga appliances natin sa bahay. Ayan. Hence, the inverter output matches the voltage within the house that is coming from the grid. So, ayan nga. So, traditionally, sabi dito, meron pa tayong dagdag kaalaman dito, there is usually one central inverter in a solar system. A more recent invention has been the microinverter. Microinverters are connected to individual solar panels so that each individual panel provides a high voltage alternating current. So, ayun. Meron tayo dito two types of inverter, which is the pure sine wave inverter as yung modified sine wave. To make it short, yung pure sine wave, it is capable of producing cleaner, smoother, quieter, and more reliable electricity to operate appliances and electronics without interference. So, ibig sabihin, mas cleaner, mas smoother, mas quieter itong pure sine wave inverter kaysa sa modified sine wave inverter.
The DC protection device and the AC protection device. The AC SPD are placed parallel to the AC CD. Just like the DC SPD, this serves as protection against transit voltage, but this time on the AC side of the PV system. SPD redirects this excess power to the ground. Multiple equipment connections on the grid, either internal or external, can also be cause of electrical anomalies where power surge could also arise. Time delay switch. This can also be called as power on delay. It delays the turning on of any electronic device for a desired time interval. This device serves its useful purpose usually when brown out. Of course, after a brownout, when power have already been restored, there is a tendency of power surge which may damage the system if it's being turned on right away. To prevent this, time delay switch delay the turning on of the system for a minute or even a bit more. And the programmable timer switch. Turning the solar power system on and off would be a vital routine which cannot be perfectly done in a day-to-day basis. Programmable timer is a hassle-free switch that automatically turns the system on and off at your desired time. Solar-powered home grid type, the net metering. First question, what is net metering? Net metering allows customers of distribution utilities to install an on-site renewable energy facility not exceeding 100 kilowatts in capacity so they can generate electricity for their own use. Any electricity generated that is not consumed by the customer is automatically exported to the DU's distribution system. The DU then gives a peso credit for the excess electricity is be equivalent to the DU's blended generation cost, excluding their generation adjustments, and deducts the credit earned to the customer's electric bill. For the question number 2, is net metering already available in the Philippines? On 27 of May 2013, the Energy Regulatory Commission adopted ERC Resolution 09, Series of 2013 approving the rules enabling the net metering program from renewable energy. This resolution was published on 10 of July 2013 in newspaper of general circulation in the country that took effect 15 days thereafter. Thus, the net metering rules took effect in the Philippines on July 24, 2013. The net metering program is available only to an grid distribution system or DUs connected to the transmission grid. For the question number 3, what benefit will I get if I go into net metering? By generating electricity for own use, you reduce the amount of electricity you buy from your local DU. The rate of savings or avoided costs realized on electricity generated for own use is equivalent to the DU's retail rate consisting of charges for generation, transmission, system loss, distribution, subsides, taxes, and other charges. You also earn peso credits on any excess electricity exported to the DU equivalent to the DU's blended generation cost, excluding other generation adjustments. The peso credits earned is then used to reduce your electric bills. Question number 4, how will my DU monitor the excess energy that my grid-tied setup is exporting towards the grid? The DU may OPT to install 2 unidirectional meters, one to meter energy you buy from your local DU, and the other to meter the energy you export to the DU. The DU may, at its opinion, install a single bidirectional meter that can meter both import and export energy if it finds it to be a more economical. The DU may also install a third meter in proximity to your RE facility to meter its total RE generation. The total RE generation should earn for the host DU RE certificates, which the DU can use to comply with its renewable portfolio standards applications. And for the question number 5, who are qualified to participate in the net metering program? DU customers who are in good credit standing in the payment of their electric bills. To their DU are qualified to participate in the net metering program for renewable energy. These customers are referred to in the rules as qualified end users or QE. In the case that solar power system is being installed and does not apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. Another example is when the solar array is rated at 5 kilowatts and the load consumption is only 4 kilowatts. The system will have excess of 1 kilowatt, which will be sent to the grid. This excess energy will pass through the meter, hence will be billed to the owner. For the another question is there any other way besides net metering that a customer having solar power system producing excess energy during the day and yet will not pay for it? The answer is yes. This can be achieved by using an inverter with limiter. This device limits the power that the system will dissipate. It automatically detects the maximum power that the system can provide without the excess being sent to the grid. For the solid powered home grid-tied circuit connection, dito sa picture ay ipapakita kung paano yung connection ng bawat isa. Ayan. And solar panel, DC-SPD, DC-CV, yung input and output, TDS and AC-SPD, RCBO, and the panel board. At sa last ay pinapakita dito kung paano yung pinaka-connection sa main panel board. Ay makikita dito yung sa picture yung mga connection.
Solar powered home grid type, wire sizing and wire type. Solar powered home grid type. So first ng is yung TW. TW is thermoplastic wire moisture resistant and flame retardant. So ganito po yung kanyang itsura. Next, THHN. So ano nga ba meaning ng THHN? Thermoplastic high heat resistant nylon coated wire, or THHN, is a single conductor wire with PVC insulation and a nylon jacket. It's commonly used in conduit as electrical wire for buildings. Its heat and oil resistance makes THHN a suitable wire for appliances and machine tools. So ano nga ba itsura niya? So ganyan po yung kanyang itsura. So yung nasa pinakaibabaw po is yung nylon jacket, over insulated. So yung next naman po yung kulay green is yung PVC insulation. And syempre yung kanyang stranded wire na soft annealed stranded copper. Next, THHN-DHWN-2. THHN stand for thermoplastic high heat resistant nylon coated. THWN wire is the same, but the W stands for water resistance. The main difference between these two strands is their maximum temperature in wet location. So itsura niya, ganyan po yung kanyang itsura. So next, THW, thermoplastic heat resistance wire, moisture resistance and flame retardant. So ang itsura niya po is ganito. So next, the letters indicate specific properties of the wire insulation. T stands for thermoplastic, H stands for heat resistance, HH means highly heat resistance, W rated for wet location, and nylon coated for added protection. Next. So this is the AW cross-sectional area in centimeter. So meron po dito yung size, cross-sectional area, weight, overall diameter. So dito po yung mga sukat ng mga wire. Next. So dito naman po is yung standard ampere rating for fuses and inverse time circuit breaker. So hanggang 6,000 ampere po yung meron tayo ngayon. So diba? Imagine kung gaano kalaki yun and kung gaano kalakas. Next, this is the PV cell specs, Trina Solar and Jazz Solar.
Solar powered home grid tied circuit breaker sizing. Circuit breaker sizing, first thing to consider in sizing of a circuit breaker for photovoltaic system is the ruling in PEC, which is state that photovoltaic circuit current is continuous. Thereby, the minimum OCPD rating is 125% of the maximum current. PEC 2017 Article 6.90.2.2 and B The article is 6.90.2.38. Therefore, in the reference to the problem in conducting conductor sizing, on the DC side, the max current is 15.23 ampere multiplied by 125%, that is 19.0.4 so we can use 20 ampere circuit breaker. And sa AC naman is, since the inverter rating is 1 kilowatts dividing by 220 volts, the current will be 4.5 ampere multiplied by 125, so that is 5.625 ampere. So gagamit tayo dito ng 6 ampere circuit breaker para sa AC or RCBO. Circuit breaker sizing. Revisiting our number 10 THHN or thermoplastic high heat nylon stranded wire ampacity at 30 degrees Celsius. Correction due to ambient temperature 36.4. Correction due to rope wire distance is plus 20 equals to 59 degrees Celsius. 0.71 equals to 21 ampere. Solar powered home grid tied surge protection device. Ito po yung example ng surge protection device. Ang ginagawa po nito is pinoprotektahan niya po yung device kapag halimbawa nagkakaroon po ng pagkidlat, ganun. So possible na magiging safe po yung device nyo kapag meron po kayong surge protection device. Siya po yung nagko-control para hindi doon mapunta sa mga device yung for example nga po kumidlat, ganun, o tumama sa solar, hindi po maapektuhan yung appliances dahil may surge protection device po tayo. Surge protection device sizing specs in nominal discharge current, IMAX, maximum discharge current, UC, maximum continuous operating voltage or MCOV, and last is UP, voltage protection rating or BPR or surge voltage rating or SBR or clamping voltage. Next is solar powered home grid tied solar panel orientation. Solar panel orientation on those countries located at the northern hemisphere. Solar panels should be facing south direction for maximum sunlight, while in the southern hemisphere it should face north. Since the Philippines is above equator, it's belong to the northern hemisphere, thus solar panels should be facing south direction for the maximum efficiency. So pag sa Philippines po tayo, ang solar po ay dapat ay nasa south. Nakatapat po dapat siya sa south. A general rule for optimal annual energy production is to set the solar panel tilt angle equal to the geographical latitude. Essentially, the closer a solar panel is located to the equator, the more the panel should be pointing straight up. The closer and the panel is to the poles, the more they should tilt toward the equator. Therefore, in the Philippines, the solar panel tilt should be 12 to 14 degree. So dapat po naka-tilt po yung solar nyo. Kapag install nyo po siya, dapat naka-tilt po siya ng 12 to 14 degrees. Dito naman po tayo sa may zero bill computation. Compute for monthly average kilowatts per hour. Use 300 kilowatts per hour per month. Convert to daily usage. So 300 kilowatt mo per month, i-divide mo siya sa 30 days. So, kalabasan niya is equals to magiging 10 kilowatts na lang siya per hour and per day. So, equals yun sa 10,000, may 10,000 watts per day. Notes in the Philippines, peak sun hours is 5 hours. 5 hours po yung mapipik ng solar mo kada araw. For a solar array, rating 10,000 plus 5 equals to, divide 5 equals to 2,000 watts. For zero bill assurance, 2,000 times 1.1 equals to 2,000 watts. Number of panel is 2 to 300 equals to 7.33 equals to 8 solar panel.